Hey guys, we're going to learn about probability. Another name for probability that you may have come across is chance. Probability, chance, they mean the same thing. So what does chance or probability mean? Let us find out. Probability is the measure of how likely an event is. So we're measuring the chances of something happening. The chances or the probability of you passing your maths exam. The probability of your favorite soccer team winning the grand final. The probability of rain or sunny tomorrow. It just depends on the probability of something happening. Let us look at the line, the scale that we use when we're measuring probability. We can see that this scale starts from 0 and ends at 1. 1 meaning 100%. 0, we refer to it as nothing, as in it is impossible for that event to happen. It is impossible. So 0, there's no way it's going to happen. An example of that would be a human living without oxygen. It is an impossible event for that to happen, for a human to live without oxygen. So we say it is impossible. The chances are 0. Then on the other side of the scale we have 1. 1 meaning 100%, which is certain. That an event is certainly going to happen. It is for sure going to happen, 100%. We have these two ends in the scale. Impossible is 0 and 1 right at the end is 100%, it is certain. So in between we have as well some measurements. Right in the middle we have an even chance. Even chance meaning 50%. 50% meaning it can be one or the other. It has an even chance of happening. So we say it is an even chance, it is 50%. So tossing a coin, for example, there is a 50% chance it's going to be a heads and a 50% chance it's going to be a tails. So we say it is 50-50 or even chance. Then we have from 0 to 50% or 0 to 0.5, which is the same as 50%, is unlikely, meaning it is less than half. Less than half. It is a small chance of happening, meaning it is unlikely, it is an unlikely event that it will happen. So the term that we use is unlikely. That event most likely will not happen because it is less than half, less than 50%, between 0 and 50%. Then we have above 50%, all the way to certain. Between 50% and 100%, we call that likely. Likely meaning it has a high chance of happening, a high probability of happening. It's very important that we understand this scale. It starts from 0, impossible, it goes up unlikely all the way to even chance, and then it goes up likely of a chance or of an event happening, up to 100% certain, where it is certain that that event will occur. Let us look at some more theory. It is important to understand that in probability, the majority of times we're going to write it in fraction form. However, sometimes we can write it in decimal and in percentage, but the majority of times when we say find the probability of an event happening, we write it in fraction form. So looking at this theory, it says the probability of an event occurring, the probability of something occurring, equals the number of outcomes for that event over the total number of outcomes in the sample space. Now that's a lot of words. It can be technical. With a bit of examples, you're going to see how easy it is. All it's saying is that the number of outcomes in that event is divided by the number of outcomes in the sample space. What is sample space? Meaning the total events that are there and the outcomes that we're looking for over the total, that is the probability of that event happening. Now, the theory may be confusing. However, with examples, you're going to see it is very straightforward. But we have to go through the theory just to give you an understanding before we go through the examples. The formula we use is P open bracket E close bracket, which means the probability of that event, the probability of an event happening equals the number of that event over the number in the sample space. So that formula is basically short form for that theory right on top. Now let's do examples. It will make your life much easier. You understand it and you'll notice it is very easy. Okay, example time. It's going to be easy now. Once we go through the examples, it will become very straightforward. So the first example says, once we throw a dice, we can get the numbers 1, 2, 3, 4, 5 and 6. What is the probability of throwing a 5? We know the formula. The formula says the probability of an event, the probability of a 5. The question is asking, what is the probability of throwing a 5? The probability of a 5, the event, the E is 5. The question is asking, what is the event, what is the probability of throwing a 5? Here we normally have the event, which is the 5 in this case, and the number of the event. How many 5s are there on a dice when we throw it? We know there's only 1 5. That's the number of the events in that sample space. The sample space, 1, 2, 3, 4, 5, 6. The total outcomes available on a dice are 6, 1 to 6. So how many 5s are there? 1. The number on the sample space, how many are there? There are 6. There are 6 numbers in a die, so the probability of throwing a 5 is 1 out of 6. It is that simple. It's very easy. So the probability of throwing a 5 is 1 out of 6, and here 1 5 out of the 6 numbers that we can get on a dice. So the probability of throwing a 5 on a dice is 1 out of 6. Next one. What is the probability of throwing a number less than 7? A number less than 7. So in this example, or in this question, what is the probability of throwing a number less than 7? We think about it. In a dice, 1, 2, 3, 4, 5 and 6, all the numbers are less than 7. So the probability of less than 7, how many numbers on the dice are less than 7? There are 6 numbers on the dice less than 7. How many numbers are there altogether on the dice? There are 6. That means 6 divided by 6 is 1. So the probability of getting a number less than 7 is 6 out of 6, which is 1 whole, which means it is certain. All the numbers on the dice are less than 6. So 100% or 1, which means certain. The event of throwing a number less than 6 on a dice, or less than 7 on a dice, definitely will be a certain. All the numbers on a dice are less than 7. So 1 whole, meaning it is certain. The next question says, what is the probability of throwing a 0? Again, we write it down. The probability of throwing a 0, the probability of the E, the event here is 0. What is the chances of throwing a 0? Well, we know, are there any zeros? What is the probability of throwing a 0? The chances of that happening? There are no zeros. There are no zeros. How many numbers are there on a die? There are 6 numbers on a die, 1 to 6. There are no zeros. There are 0 zeros on there, which means our answer is 0. So the probability of throwing a 0 is nothing, which means it is impossible to throw a dice and get 0 because there is no 0. It is that easy. Sometimes it may be confusing with the theory, but once we look at the examples, it is common sense. It is pretty straightforward. Let's do another example and hopefully the picture will become better and more clearer. The next example says we have 12 colored counters, 3 red, 5 blue, 2 yellow and 2 green. What is the probability of choosing a yellow counter? So the probability of yellow, the probability of the event here they're asking for a yellow counter. That is our event. How many yellows are there? The number of the outcomes, we are asking for a yellow outcome. So how many yellows are there? There are 2 in the whole sample space, in the total counters that we have. And basically the total counters that we have is 12. So 2 yellow out of 12 altogether. The probability of a yellow counter is 2 out of 12. We simplify that, which is 1 out of 6. So the chances of us picking out a yellow counter is 1 out of 6. Let's do the next question. It says, what is the probability of choosing a blue and a green counter? So here, what is the probability of choosing a blue and a green? So that's our event. We're asking for a blue and a green counter. We know that there are 5 blues, and we know there are 2 greens. So we know 5 blues and 2 greens. Out of the total, there are 12 altogether. 7 out of 12. So the probability of choosing a blue and a green is 7 out of 12. This is the probability of choosing blue and a green out of the 12 counters that we have. Let us do one more example. Last question now, which says we have 24 playing cards. Find the probability of choosing a red card. Let us see our sample space. Sample space meaning the total. When we look at the total, we can see there are 12 black and how many red? 12 red. So we know that the probability of choosing a red card is 12 out of the total, which is 24. And of course 12 out of 24, when you simplify it, 1/2. So the probability of choosing a red card is a half. Half of the cards, the 24 cards, are red. So the probability of choosing a red card is an even chance, 50-50, or 0.5, or 1 out of 2, which is a half. That is the probability of choosing a red card. The second one says, what's the probability of choosing a black card? Well, we know that the probability of black card is once again 12 out of 24. There are 12 black cards out of the total 24. A half of the total 24 cards is black. So there are half of the cards are black. So the probability of picking out a black card is an even chance. It is half, 1/2. Then the next question says, find the probability of choosing a hearts. Okay, we need to look carefully. How many hearts are there? We can count 1, 2, 3, 4, 5, 6 hearts. So the probability of choosing a heart is 6 out of 24, which is 1/4. 1/4 of the cards are hearts. So the probability of choosing, the chance of choosing a heart is 1/4, which is really 6 cards out of the 24 cards. The next one says a card less than 4. A card less than 4. Okay, let's see how many cards are less than 4. Less than 4 meaning the 3, the 2 and the ace. Okay, so the 3, the 2 and the ace from the clubs on top, the 3, the 2 and the ace from the spades, the 3, the 2 and the ace from the hearts, and the 3 and the 2 and the ace from the diamonds. So altogether there are 12 out of the 24 cards that are there that are less than 4. Less than 4, there are 12 of them, 12 out of 24, which is half, 1 out of 2. As you can see, it's important to know the cards. It's important to understand the sample space, which is the group, the outcomes. All the outcomes we have there are called the sample space. Here, we're asked a card less than 4. There are 12 cards altogether out of the 24 that are less than 4, which means half of the cards are less than 4. The last one, it says what is the probability, or find the probability of choosing an ace. How many aces are there? We can see 1, 2, 3, 4 aces. So there are 4 aces out of the 24 cards altogether. We simplify that and we know 1 out of 6. The probability of choosing an ace is 1 out of 6. Here, 4 cards, there are 4 aces in 24 cards. We know that means if we simplify it, 1 out of the 6 cards will be an ace. So the probability of choosing an ace is 1 out of 6. This is the basics, the introduction for probability. Very important to understand it. It is very easy. It is just basically looking at the outcomes and finding out how many events occur, putting it in fraction and then simplifying it. It is pretty easy. Look at it and understand the examples. The theory will become much easier.